Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a square divided by square root of a is equals to a, and we solve this problem for all the values of a. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move toward the solution of this problem from first method, and here you see that this is a square. We write this a square as a multiplied by a, and it is divided by square root of a is equals to a. And further in the next step we need a little bit more simplifications, and here you know about that if we have any number b, so we write this b as in the form of product of two radicals in this way. So this is b square root of b multiplied by square root of b is equals to b. So according to this rule we write this a as in the product of two radical terms. So we write our above equation as in this form. So this will becomes here a multiplied by square root of a multiplied by square root of a divided by square root of a is equals to a. And now in the next step you see here this square root of a is cancelled out by this square root of a, and after cancellation of these two terms we get the remaining values are a times of square root of a is equals to a. And now here in the next step we need to move the term a from right hand side to the left hand side, and it will becomes a times square root of a minus a, and this whole equation is equals to 0. And now here in the next step we need to take common a from here, and when we take common a from both of these two terms we get the remaining values are square root of a minus 1, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write a equals to 0, and the second case is we write square root of a minus 1 is equals to 0. So this is the first root of the given equation, and from here we move this minus 1 to the right hand side, and it will become square root of a is equals to plus 1. So for the values of a, here we again take squaring on both of the sides. So when we apply squaring it will becomes here these 2 and square root are gone, and we get here a is equals to this is 1 square, and 1 square becomes here plus 1. So this is the value of a which we get here in this method. So these are the two values of a, and now here in the next step we need to verify that is this value of a be the solution, or is this value of a be the extraneous root. So for verification of these values we need to copy down given question statement. Here it is a square divided by square root of a is equals to a. This is our given question statement, and in this side we will be verify a equals to 0, and in this side we will be verify a is equals to 1. So here we substitute a equals to 0 into the given question statement. So it will becomes here 0 square divided by square root of 0 is equals to 0. And in the next step we have 0 square becomes 0 over square root of 0 becomes 0 equals to 0. So in the left hand side you see here we have this will becomes 0 over 0 form, or in other words we call that it is indeterminate form. So if our left hand side is indeterminate form, or in other words our left hand side is undefined, this means that both of the sides are not equal. And if both of the sides are not equal, this concludes about that the value of a equals to 0 is not satisfied our given question statement. So we call that a equals to 0 be the extraneous root of the given equation, because it does not satisfy our given question statement. So in the next step we need to verify the second value of a, and here we substitute a equals to 1 on both of the sides, and it will becomes 1 square divided by square root of 1 is equals to 1. And here you clearly see that 1 square becomes 1 equals to 1. This means that both of the sides are equal, and if both of the sides are equal, this concludes that the value of a equals to 1 is satisfied our given question statement. So we conclude about that the solution set of this problem is a equals to 1. So this is the only one solution of the given equation. And now here in the next step, we again solve this problem for second method. So for second method, we need to copy down given question statement here. And our given question statement is a square divided by square root of a is equals to a. So in the second method, we move this square root of a to the right hand side, and it will becomes a square equals to a times square root of a. And in the next step, we need to remove this square root sign, and for this we take squaring on both of the sides, and when we apply squaring, it will be written as a square and its whole square equals to a times of square root of a and its whole square. And in the next step, we have this is a square and its whole square becomes a to the power of 4 equals to this is a square, and the square of square root of a is cancelled out by each other, and we get only a. This case is implies that we get a to the power of 4 is equals to a square multiplied by a becomes here a cubed. And now here in the next step, we move this a cubed from right hand side to the left hand side, and it will becomes a to the power of 4 minus a cubed, and this whole equation is equals to 0. And now you see here both of these two terms involve a cubed, so that we will be take common a cubed from here, and we get the remaining values are a minus 1, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write a cubed equals to 0, and the second case is we write a minus 1 equals to 0. So from here we easily get the value of a equals to 0. This is the first root of the given equation, and from here we get the value of a is equals to plus 1, and this is the second root of the given equation. So in the second method, you see here we again get these are the two roots of the given equation, but in the first method we already verified that a equals to 0 is not satisfied our given question statement, so we call that a equals to 0 be the extraneous root of the given equation because it does not satisfy the given question statement. And finally we conclude about that a equals to 1 be the solution set of the given equation because it is satisfied our given question statement. So the verification steps you can see in the first method. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more interesting and exciting videos, and thank you so much, and bye bye.